Okay, so the next question was, now this is a functions question, but we actually did this when we were looking at the indices chapter, learning how to draw indices graphs, and we'll be talking about them again because they come up in both chapters. So anyway, the first one is 2 over e to the x. So all you really have to do is you come along and you fill in 0 there, you fill in 0.5 there, you fill in 1 there, and here you're going to literally fill in natural log of 4. For the bottom one, again, you're just going to fill in your 0, your 0.5 minus 1, your 1 minus 1, and your e to the natural log of 4 minus 1. So you end up with anything to the power of 0 is 1. So you end up with 2 there. You end up with, when you put that into your calculator, 1.21. Now it's correct to 2 decimal places. Some of you got carried away there. This is worth 10 marks. And you didn't do 2 decimal places. So this is 0.74. This was 0.50. This one ended up being 0 because anything to the power of 0 is 1. 1 take 1 is 0. Here we have, I'll just write it here, 0.65. This one is, what was that one? 1.72. And the last one was 3. So you ended up with all your couples. So your couples here were 0, 2. Now the calculator confirms this as well, of course. So 1 and 0.74. 0.74, I'll write actually. Sorry, I'll just write that neater. So 0.74, and then the natural log of 4. Now, for the natural log of 4, that's 1.39. So, because when you go to graph it, you need something more, you can't really graph negative natural log of 4. You kind of need a figure there. So that's why I've done that. And then the second guy is going to be this. So all we're going to do now is plot those. Now, generally people did very well in this, but just the 2 decimal places thing was a problem. And I'm just replacing natural log of 4 again with 1.39. So then I go down here and I plot that. So 0, 2 is there. A half and 1.21 is about there. 1 and 0.74 is probably about there. And 1.39, now I kind of would visualize where the 2 is, so that I can then visualize where the 1.39 is and 0.5. So that's about there. So my graph kind of looks like that. Then the other one, and it's not a straight line. I think there was 1 or 2 people who drew kind of a straight line. So just be careful there. The other graph then is 0, 0, a half 0.65, 1 and 1.72. And then 1.393. So this one, again, it's not a straight line, it's slightly curved there. But anything within reason, 5 marks. Now, if you had messed up the table and you have an FT, it just means follow through and you get the full marks. So if you make a mistake up here, but then you graph it correctly, you get the full 5 marks. You're then asked to use your graph. Now, I keep saying if it says use your graph, you need to show the dotted line. Not everybody did. So it's asking you where do they intersect. Don't just stop there. It's asking you for the value of x. So you have to do the dotted line. Now the answer here is nearly irrelevant as long as you're doing that dotted line. So about 0.7, and that was worth 2 marks. Again, if you have an FT there, it means your graph might be awful, but if you still showed where they intersected and did a dotted line, you got the full 2 marks. It then says we have to show it using algebra. I might just do that out here where I have a bit of space. So what you're being told to do is you're supposed to allow f of x to equal g of x. So essentially, you're just allowing them to be equal. Now, this is worth 10 marks. Some of you only got as far as that, but at least you did do that compared to some people who didn't do anything at all. So what do I do now? So what I do is I'm going to start off, and the same as I would do in any algebra question, if I have one fraction, I'll write everything as a fraction. Cross multiply. So I don't know why people didn't do this, but I mean, this is literally just your normal rules of algebra. What do I do then? Well, e to the power of x multiplied by e to the power of x is e to the power of x squared minus, now if I multiply e to the x by -1, that's minus e to the x. So there seem to be a few issues around that. That's just algebra multiplying. One or two people changed it into y. If you did that, well, maybe it would have made it easier, y squared minus y. I will eventually change it to y anyway. So if you want to change it there, do, and it might make the multiplying easier. So anyways, what this ends up becoming really is e to the power of 2x, or you can leave it as x squared. It makes no odds, and that's the other one. So at this stage, I let e to the power of x equals to y, and 2 is equal to e, sorry, not e, I've replaced e, so it's going to be y squared. That's going to be y squared minus y. And I bring everything over to be a quadratic. I use my null factor theorem, open up two brackets, y there, y there. The minus means I have to have one of each, 1 plus, 1 minus. So factors of 2 is going to be 1 and 2. I need the -1, so in that order, I allow each one to equal to 0. And I end up getting that y is -1 and y is 2. Now, before I finish, I'm not done until I sub back in. So I'm going to allow this to equal -1, and I'm going to allow this to equals to 2. Now, when I do that, is there any way I can get a negative? I can't, because even if you do a negative, like even if you had e to the power of -3, that is 1 over e cubed. So it's never actually negative. So a negative is not a possibility. So that should be crossed out. How do I extract out the x? Well, hopefully you knew that this was logs. I mean, the whole point of logs is that you can extract out that x. So you have, okay, a log of your base is e, so it's e2 equals x. Okay, so then we end up with, that's the natural log of 2. And then the natural log of 2 is 0.69. And as I said, that was worth 10 marks. So I'll stop recording there and we'll do the next one separately.